Hello, welcome to the tutorial, and today we're gonna test the R tutorial in Economic Statistics course Econ 304. So now we are in the R Studio software, and we start with having three windows in the program. First one is the console. So the console will contain the calculation in the programming. So all calculation will be in here. So start with the version of R that we're running. So in my computer I'm running R version 3.3.0 that released mid of last year, and is supposedly educational. There's some description about R. That is a collaborative project that many contributors with many contributors. Okay, if we want to know who are contributors, you can click on this, paste and run, and it will show R information. The origin, the authors of R, and the names come from the two persons who created R, Robert Gentleman and Ross Ihaga. We know them as R&R. And the main teams, very good people who are running this, starting from Douglas Bates, John Chambers, Peter Derrickard, Seth Falcon, Rob Gentleman, Kurt Hornick, Ross Ihaga. Names goes on. Okay, I'll close this. And the next window is the environment and history. The environment will show all the files that we have in the working directory now that we have. So the environment is empty at the moment, so I have nothing here. About the history will contain all the function that we have done before. So you can go back to the function that you have run through it. Okay, I have very many. However, we can go back to environment. The third one on the bottom right will contain 5 main things. The first one is the files. Files will show all the files in the folders, basically in the files of the Mac and also the window in the Microsoft window. The next tab will be the plots. The plots will show all the plots that we created in R here. You can export the plot later by save as image or save as PDF. Third one is the packages, because R is a computing environment. This is very basic, but researchers or the programmer can create the packages that extend the capability of R. And there are thousand packages, and it's created every day. So if you see the list of a name here, these are the packages that we already installed in my computer. The box before the name saying that this package hasn't called to use yet. If you want to use it, we click here, and suddenly the command that we use is a library. Okay, so if you want to use any package, you just type library. Okay, so in the console, all calculation occur here, and also any function that you want to use. So let's say I want to use the package called SPack. I just type library, open the bracket, and I say AC SPack. And RStudio will show us the package that they have in the system, but we want to keep typing. Okay, and just enter. When I enter, become tick here. Okay, So that's a package. Help is like the attached manual of R into it. So if I want to know about the plot, so I type plot, enter. So it shows the function that related to the terms I search here. It's called plot, and this is a plot function in the package graphics, and it is a generic XY plotting with a description, usage, argument, so on. And what I like is the help provide with examples, so you know how to use it in the program. And finally, is a viewer. It's a general viewer that we can use. We have seen 3 windows. The last one is probably the one that we work with the most. But to call for it, we have to go to File, New File, and R script. Okay, even though you can type anything in the console to calculate or do some mathematics or statistics operations, but you hardly keep it and reproduce the same result maybe in the next month, next year, and so on. So you can type 1 plus 1, enter, you have the result 1 power 3, 3 power 2, 4 over 2, something like that. Or even you have the data. Let's say I want to call on the data that's called cars. I enter and I create the dataset called cars. I take it from the dataset package, and I want to plot cars, and I do have speed and also cars, and I have distance. Enter. So the plot show on the bottom right. You know, this plot between car distance and speed. If you want to repeat the previous command line, I just click on the arrow that point to the top. I may change something here like xlap, have xlap equal to speed of the car, and it is mile per gallon. Run it. Let's change here, become speed of cars. Come back to console, click up, maybe ylap equal to distance, enter. So change to distance here. But if I want to keep all the command here or the script here, it's difficult because console containing the current calculation and programming. We're going to keep all the function and all the code in here in the script one. So now it's untitled. So let's say I'm going to save, click on, sorry, I use a shortcut. So click on save here. Okay, so I name sample, I name test, paste it in desktop perhaps, enter. Okay, it's going to be black when we save it already. If you haven't saved it, it will be red. So if I type hashtag, become red. I click on save the disk here, become black. In R, the program will ignore any text on that line that behind the hashtag or the sharp symbol. So we use the hashtag to start with the description of the command code. So normally start with the hashtag and saying, explaining what I'm going to do or what it is that we're doing now. So say this is a test of the programming programming. Okay, it's red because I have updated the save. Click on it. I think for ECOON304 economics statistics. Okay, say faculty of economics, Chiang Mai University by Parish people. Do it. Call me attention. Okay. So we kind of set all the 4 main windows in our studio. You can change the size of each window by dragging at the border at the edge. So up to you. Normally I want a bit more space for the console and the script. If you want to really change it, you can look at the tools and go to the global options. In the global options, there are several categories that you want to change. Normally, I will change the appearance. I think Monaco font is quite good for the programming. Font size, you can increase, decrease, but I think 10 is not that bad. And then the editor themes, so TextMate, or I myself actually use Cobalt. Okay, so the background will be the navy and colorful text for each type of the text function, objects, comment, and so on. Let's say apply this. Not so sure you like it or not. So we have slightly smaller text. Okay. Well, what we're gonna do next? So on the top right, we have cars as a dataset that I import from the basic package. So I'll say in R there is a there are dataset installed for us to use as samples. Okay, that package called dataset. What I like in R is that the functions and the other names is very what can I say, explainable, self-explainable, so you can know straight away what it is. So I want to know what about the dataset. So install it. I think it's there already, so type question mark. If you want to know anything in R, you can type question mark and followed by that things and run. So click run. Okay, so now on the bottom right, there's some description about datasets package. So say the base are datasets, and the details is that this is a package contains a variety of datasets. For complete list, use library help equal to dataset. So let's copy this, paste on the console and click run. So the click run shows all the datasets available, so plenty of it. For cross-sectional, there are not so many. Economics dataset. But what I like is the cars, the empty cars data. For car package, that we have the only 2 variables, which are stop speed and stopping distance for the cars. Euros will be conversion rate. I think it's over time. I can start to type about it. It says euros is very static. It's quite useless. Going back, I've teaching this for a long time. The most useful one will be the empty cars. Empty car runs, and the empty cars data contained the data about cars in, I think, long time ago. It's Mazda RX-4, and we have 1 2 3 1 2 3 4 5 6 7 8 9 10 11 variables. Start from miles per gallon, cylinders, and so on. Not so economics. One package that helped us a lot is called AER. So now we will install a new package called AER. It stands for Applied Econometrics with R. Okay. To install it, we type install.packages, open the bracket, do some typos, install, and quotation, and type the package name. Be careful because R is the case sensitive, so if it is capital, we need to have all capitals. Okay, so this command is used to install the package. Okay, I'll comment that just do once to get the package. Okay, like buy a book, because you just buy a book once and that's it, right? You keep the book in your library. Okay, so I run this line. In console, the commands coming in, okay, and the cursor is peep peep here, so it's waiting to do something. And now the R is starting to download the AER packages from the cloud. Okay, so it's starting to download. Okay, when it's finished, the greater than symbol will show and the cursor will be there to ready. Okay, so when we buy a book, next thing we want to use it, so we have to go to library and take the book that we want. The package is the same, so to use it, we use library, open the bracket, quotation, AER. Okay, so do it every time you restart the program and want to use it. Okay, so a quick run. But before I quick run here, if you go to the bottom right and click on the package, you will see that we have AER ready for us. Okay, when I run line number 15, the box here will be thick automatically. Keep your eyes on it. Okay, a quick run, 1, 2, 3. Come on, come on. Take some time. So now in the console is loading, require library. Yeah, AER is tick here. So we ready to go. Save to make it black. Okay, so in AER there's a data called, there is dataset, called CPS 1988. I like it. It is a wedge dataset. Wedge dataset. Okay. So type question mark CPS 1988 and I click run it. Okay. So the bottom right, I have the CPS 1988 in the AER package, and this data is determinant of the wedge data in 1988, and it is cross-section data originating from March 1988 current population survey by the US Census Bureau. Okay, to use it, it's data CPS 1988. Okay, so I type data in bracket quotation CPS 1988 and I'm gonna run it. When I run it, look at the top right. I will have the new data below the cars. Click run. Yeah, so I have CPS 1988. There are 28,155 observations and there are 7 variables in there. Okay, so I have some comment. Get the data set from AER package. Get the data set to the environment. Okay, so this is environment, our environment. So there are 2 datasets in our environment, cars and CPS 1988. Okay, and we want to know what are the variables in there. Okay, so say we want to call for the variable names in the CPS 1988 dataset. The keywords is the names. We want to know the names. So in R, the function is very easy. It's just the names. Okay, and CPS 1988. And we click run. Okay, so this function, this command will pass to the console. Okay, the command is here, and the console shows 7 variables starting from wedge: education, experience, ethnicity, SMSA region, and part-time. If it is your data, you know exactly what it is, but here is in the R. So if you look at the format on the bottom right, so we know that the wage is the wage in dollars per week. Education is the number of years in education. Experience is number of years of potential work experience. Ethnicity is a factor, so qualitative data. And there are 2 values, CAUC in Caucasian, and AFAM is African American. SMSA also the factor that answer to the question of does the individual reside in a standard metropolitan statistical area, SMSA, city center or not. Region will be Northeast, Midwest, South, and West. And the part-time also the factor about does the individual work part-time or not. Okay, so we have the data, and the key part is to determine the wage of individuals in 1988. So let's say in the regression model we would like to predict the wage. Then we develop a model that can explain variation in wage. Okay? In this case, we have education experience because we're doing economic statistics, not just statistics or data analysis. That just do it. We have theory. Okay? In labor economics, Mincer's model is classic. Is the classic wage determination function. Okay, is a wage is the function of education, but at the time it's called schooling, and also experience. Okay, two variables, and we got it. We got them: education and experience. Now here. Okay, I will not go into the detail how education related to the wage, whether it's linear, non-linear, or experience. We just try to simplify in the first tutorial here. Okay, really, first thing first. First thing first is to look at the data. I think it's maybe too small. Let me go back to 11. And I think you want TextMate. Are you? Okay, back to TextMate. I have to adjust my. Okay, I think we go back to Cobalt. Okay, that's better. Okay, so we have to look at the data, and it's called descriptive statistics. Okay, so basically you can do anything with it with a simple function like mean. Let me explain with hashtag and say calculating average and averages. Okay, and the function it used to calculate the average is mean. That's it. But to calculate the mean, first we have to identify the dataset, and here's CPS 1988. Next, you have to identify which variable in the CPS 1988 dataset that you want to calculate the mean. And we use $sign to split between dataset, $signs, and variable names. So use which, click on which, okay, and run. So the mean is 603. Okay, so they can copy, paste, and change from wage to experience and run. Okay, can change from wage to education and run. Okay, if I copy, let me type, say calculating standard deviation, so it is SD. copy, paste, click run. So the standard deviation of the wedge is 453.5474. Okay. I think I need a little bit more dark. That's okay. All right, and copy, experience and education. Change from mean to SD, run. Change from mean to SD, run. Okay. Other functions. So it's like max, min, it goes on. Okay, copy the wedge, paste, run, paste, run. Okay, but we want all in one. So say normally we would like to have all descriptive statistics simultaneously. Okay, and there's a package that do this for us. The package that provides that kind of function for us is psychometric. Okay, so I have to install the packages psych. So install it. Start to download the packages. Okay, it's 4.2 megabyte. Let's finish. Okay, look at the package, and psych should be somewhere around here. PSMNOP psych here. Okay, I can click here as well. Let's work. Okay, so the command is here. Just to keep it. Okay, and the function that we use, I'll say call this descriptive statistics. We use describe, right? You want to describe it. Describe, and you can take all the dataset. So CPS 1988. Run it. Come on, yeah. You have variable, number of observation, mean, standard deviation, median, the trim median, mad, min, maximum, range, skewness, kurtosis, and standard error. That's perfect. You can report this. Okay. But to develop a linear regression model, variables should be normally distributed. Okay, so we can do two ways. First is to visualize it. Okay, first is to visualize the data. So I normally use box plot. Okay, and CPS 1988, and go for the wedge first. Okay, click run. So now we plot the wedge. Zoom. What is it? Very skew and it is positive skew because we have many outliers, positive outliers. Okay, and we double check to get the numerical value of skewness. So I type skew. This is a function in the psych and CPS 1988 and wedge and run it. Oh, 6.5 is positive. So copy. This is just for the record. So skewness of the CPS 1988, the wedge variable is 6.5. So positive. So I say, since wedge is positively skewed, we need to reduce it. Okay. So we're gonna reduce by taking square root first. So I say box plot. Actually, it's very easy. Just copy and paste. Okay. I will cover by square root. So sqrt is a function to take square root, inner, and cover by the bracket. So there are two brackets here. So run it. Okay. The picture look better, but still positive skew for sure. I can also calculate it. Change to skew and run. So it's not 0.8899. So I take hashtag just in case. Still positive. Okay. The SQRT which is still positively skewed. Then we can take log. Okay, so take logarithm. So I say log of box plot and log of CPS 1988 dollar wedge run. It's look better. Have both positive outliers and also negative outlier here too. Okay, close it. Alright, I want to see the number. So I copy this, type skew and paste, run. Has become negative skew. That's okay, but it's closer to 0. Okay, log form of which is the closest to normality. Okay, so in the regression model we will use log wedge. Okay, so let's try create a linear model. Okay, so I create an object called model A. Model 1, that's okay. And I want to take the linear function form with provided data into this object. Okay, have some space and use less than and dash to become like an arrows. So anything that I type on the right hand side of the arrow will be put into model 1. Okay, and I hope model 1 will contain my linear model. The function they use is rm. Okay, if you want to know the details, you could use question mark to ask for the help, rm, and run. Okay, so on the right, bottom right will be the description of the rm function, which is in the stat package. We have fitting linear model with description, sample. Okay, so look at the usage. Okay, LM followed by a formula. My formula is wedge. Depends on user tilde. Depends on, I'll say, education. Okay, this is a basic, comma, data. Okay, followed by data, and here in this case data equal to CPS 1988. Okay, so when I run it, I will create a model, and this model should be in my environment. Okay, so click run. So I have model 1, that's a large data with the LM function, 12 elements, size is 7.6 megabyte. And nothing in the console shows now because we haven't asked anything. We just create the model. Okay, so you want to know the summary of the model, so I use summary and model 1. Okay, I click run. It shows the basic information. Okay, summary model 1, so it shows the function, the script that I have. It shows residuals with the distribution of residuals from median to first quartile, minimum, third quartile, and the maximum value. Okay, next part will be coefficients. The coefficients will provide the estimate of the coefficient, and the estimate coefficient of intercept is minus 12.8281, which is the intercept, the constant term, basically. Next will be the standard error. Okay, and estimate divided by standard error will be t-values. In this case, it's minus 1.078, and the probability that we're gonna have the type 1 error, which means that the coefficient is not exist. Okay, in this case, it's not 0.281. Okay, so the chance of the constant terms not exist is 28%, which is quite high. Normally, we will reject it. Okay, and the next estimation will be the estimated coefficient of the education, which is the slope, and type 1 error probability is very low. It's 2 times 10 to the power of minus 16, and the level of significance is 3 star here, represents 0. Actually, it's not pure 0. It's 0 point many zeros, lots of decimal place. The last part of the summary in the linear model, there are 3 lines. The first line is the residuals standard error. Okay, or RSC is 432.4. Okay, the lower is better because we don't like the error. Okay, and the degree of freedom is 28,153. Okay, and degree of freedom is the number of sample, which in this case is 28,155 minus the number of coefficients that we estimate. How many we estimate in this model? 2, right? Estimate intercept and 1 slope. Okay, and that degree of freedom will give us to the F statistics and then multiple R square. Multiple R square in this case is 9%, and adjust R square is also 9.96%, slightly less than, but it is the adjust R square that divided by the degree of freedom already, so there's no bias from the different number of the predictors. Finally, the last line is the F statistics, which is 2,818, which 1 and 28,153 degree of freedom, provide p-value, and the F statistics will test if this model is working. So it tests against all the beta in the model. So in the simple regression model, the p-value of the F statistics is identical to the p-value of the beta. Okay, right? So from the summary, we can write the linear model of model 1. So I'm now up here in the top left. So I can write that the wedge equal to constant and plus 47.181 knot here, which is a slope times education. Okay, and I will put the significance symbol in here too, just in case. Okay, I'll just comma and say R square is this one. Okay, so this is how we're gonna basically report the linear model that we have. So the estimate wedge, okay, depends on the education, but the starting value is minus. So you rarely have low years in education. So this means if labor has one more year in education, his wage will be increased by 47.181 US dollar, I guess, per week, dollar per week. Okay, so this is interpretation. The predictability of the model, we're going to look at the R square, and if we have different number of the predictor, we're going to use the adjust R square. Okay, so now we have 9%, 9.99% of accuracy. So let's say we have better model with, say, actually we should use log wedge, not just wedge. Okay, so then we create model 2 which use log wedge. Okay, so let's have RM, and the good things about R is that you don't have to create a new variable. You can just put the mathematical operations in there. So let's take a log and open the bracket with wedge, and depends on education. Bear in mind that I haven't checked the distribution of the education, yet whether it's positive, negative. So we use the same, but because we just want to see the impact of transforming just the wage from normal wage to the log wage. Okay, so we have data, CPS 1988. Okay, so run it, no error, so it's perfect. And then I call for summary of model 2 and run. Okay, very interesting. Because we reduce the size of the wage, the estimation is lower, but now the constant also significant, very high significant, and R square is increased, so 9.461, so slightly increased. So I'm gonna type the model, so it will be log wage equal to 5.1 blah blah blah. Let's say in the class we use 3 significant digits, so we have 178. Okay, so 2 we will round it down, so delete 2 and 9. Okay, plus the slope that we have here, 0.0759. Okay, so 3 significant digits, we start from 7, 5, 9, then 4, write it down, so delete it, times education. Okay, comma output, very significant. Okay, and R square is so from 9.0 to 9.4 is better. However, in statistics, because this is a sample, we have to test. Okay, when we compare and test it, we have to test if this can apply to the whole population. Okay, so we gonna statistically test if model 2 is better than model 1, and that the function that we use is ANOVA, model 1 and model 2, and run. My fault, we cannot compare because the dependent variable is different, it's log wage. Okay, so but we can see that you see the residuals is lower because we take log, but most important is the R square that increase. Okay, the R square is increased, so it's much better. Almost finally, I'll plot it. So I'll plot the plot X and Y. So CPS 1988 dollar, my X is education, comma, CPS 1988 dollar and wage. But I use log wage, so take log, cover here, and run. Should be in the plot. Okay, so the plot here is what we have. So I will put some argument to make the plot look better, because now the x and y axis is purely variable that we have here. So first I'll fix the x axis. Okay, you can also have question mark and plot. So you can see that they have several parented, oh sorry, not axis, my bad, xlab. Okay, xlab in this case should be just the years in education, but I should put the quotation. Oh, it's 2 a.m. already, so quite sleepy. Okay, ylab. So xlab stands for x label, ylab is y label. So ylab is the wedge, log wedge. So I say log of wedge, comma, enter. I want to have the colors, which is the blue. Okay, I run this first. A bit slow. Okay, it's become blue. It's look nice. I want to add more. I think that's fine. The last one will be main. So the title will be the wish. Relationship. I'll say, because it's causal relationship, so I say impact of education on wage. So I have to run this again. So I select all and run. It should be up here, the title. Come on. Yeah, impact of education on wage. Okay, so next thing is that I want to have the linear model that we predict running pass through. So I say I have function called AB line and I call model 2 and click run. So if we plot the model 2 over the plot between wage and education, it's black thin line, thin linear line as a result. So I want to change something in there. Say I want to make the color equal to red. Come on. Okay, but it's too thin, so say the line with LUT should be, I think size maybe 2. Click run. So actually it's plot over the old line. Should be bigger by now. Yeah. Not so clear, no? So say number 4. Run. Take some time. Okay. And line width, line type, line style, LTY equal to number 2. Will be dash if I'm not wrong. The dash line. How do I know? Can type question mark and A, B line and run it. It shows an argument, and previously we have the XY plot type and so on. So back to the plot. Okay, so we have the prediction here, and if you go back to the plot, we have another argument. It's called a subtitle. So we can use subtitle to explain about the model. So I can copy the function equation that we have here. I want to show in the plot here too. So I paste in the sub and run all the 4 lines from 92 to 95 and click run. So it's going to be the new plot, but with the equation of the regression model shows below as a subtitle here. Right, very nice. And we replot the AB line again. I think line is 1. Run. I don't know why my computer is slow now. Okay, so quite nice here. So if we zoom it, maybe because we broadcast. Yeah, very nice. If you like it, you can export, save as image. Okay, take some time here and you can save. Just convert to the plot as PNG. You can change wherever you want. So this is the whole part. Say last line here. So we finish for today as the introduction to a simple regression in R. Thank you and good night. So now it says this is 1st of April 2017. The time is 2:48:58 a.m. Right, and I want to save it. Click save. Okay, keep the snapshot. Alright, so I hope you kind of rehab from the class, and I try to speak slowly because I'm sleepy as well. Okay, so just beginning, 100 lines approximately, should be lower because we have some empty line in between. But all of this will allow you to understand the simple regression analysis. Next class, next tutorial, we will introduce you to multiple regression and also the post hoc diagnosis to test if we satisfy all the assumptions in regression or not. And later on, we're gonna introduce you to the generalized linear model when we have, the multinomial regression, nonlinear regression, probit logic where the dependent variables is limited. Okay, so hope you enjoy our. My name is Pirate Pibunung Road. Everyone call me Ajahn Sham at the Faculty of Economics, Chiang Mai University. This is a course for economic statistics, economic 304, and today is 1st April 2017. 2 a.m. in the morning, or 10 to 3 in the morning. Okay, very sleepy now, and thank you very much for watching this tutorial. I think we finished. Bye bye, good night, ta-da.